a little bit of difficulty with. Okay, we should be live. I have 3 human beings in here. Welcome. Very nice to have you along. I'm going to now share my screen, and then I'm going to ask you guys if you have any questions. So let's see if this sharing of screen thing works the first time today. And I maybe have to be a little more patient. Okay, you got it, Professor Johnson. How about you, Andrew?
You have audio? Can you hear me?
Yes, I do.
Okay, just making sure.
And can you see that screen that says questions on the top?
I can see that screen right there.
Noah, are you good?
Yeah, I can see it.
Oh, all right. Well, those of you still out there, possibly viewing on YouTube, don't forget you can contact me. Use that messaging system. Okay, here I just got a message. It looks like we are connected. It says it flashes to the screen and then back to your picture, and then I got all fixed. Thank you. So maybe we just needed to wait a second. All right. So let's get started. Questions on lesson 1.4, quadratic equations. That's how we're going to begin. Noah, Andrew, anything on that assignment that you'd like to talk through?
Could we quick look through 93?
Absolutely. Number 93. Okay. All right, I'm going to make a screen for that. Number 93. Okay. So number 93 says negative 0.067 x squared minus 0.852x plus 1.277, and that equals 0. Directions. Solve using the quadratic formula. Round your answer to 3 decimal places. So, all right. Who asked me about this one?
That was me.
Andrew?
Yep.
So I take it you just plug the numbers in?
Right.
Okay, I'll tell you what. Can you tell me what the quadratic formula is, please?
Right. It's negative b plus or minus the square root of b squared minus 4ac, and then all of that divided by 2a.
So I take it when you did it, you didn't agree with the back?
Right, yeah.
Huh. Okay, well, since that's just about all calculation, I don't know. That might not be the best problem to do here, but
Right.
Or maybe we can hang on at the end and I can do it with you.
Yeah.
So you obviously used what the book asked you to. Let me just double check. What's A?
A, that was negative 0.067.
What is B?
B is negative 0.852.
And what is C?
1.277.
Okay, so I'm not sure. That's.
Yeah, now I'm looking at my notes. I think I probably added a 0 somewhere. Yeah, that's probably what I did.
Why don't you just double check, go through it, crank it out again, and then if we still need to talk about it, let's do that.
Gotcha.
We have somebody else. I'm not sure who. We have another person joining. Good. Let's see if I can tell who that is. Nathan. Nate Zambo. Welcome. I don't have your picture, but are you there, Nate? Okay. Well, anyway.
Oh, I was thinking.
Yeah, there we go, Nate. Hi. How are you doing? We have
Doing
another.
good.
Oh yeah, so
You can. Okay, you can keep. Yeah, I see you muted your mic. That's fine. Whatever you like. Did anybody? Let's keep going on questions on 1.4. Anybody? Sorry, I'm so elated to have human connections here that I'm getting off track. 1.4 problems. Noah, any you want to go through? By the way, Noah, I hope your trip and your family connections went well.
I just got in last night.
Yeah, it's nice to have you back. A lot of traveling.
Yeah.
How's the family doing with that death?
They're all right. A little sad, but you know,
Yeah.
expected.
Well, we're good to have. It's good to have you back.
Thank you.
So I'm not getting any messages. Let's just say going once. Anybody else? 1.4 questions. I know I only got one question and I didn't go through it, but because it's really just arithmetic, I think we'll take that other approach with that. Anybody else? 1.4. All right, then I'm going to start on the new lesson. I gotta move my get my navigation down here. Okay, so this is lesson 1.5, and it's all about complex numbers. Yeah, just a graphic on here. I'm sure you guys remember this from your previous algebra class. I is defined as that. We're just setting up some kind of a name for the square root of -1. And I know you see, it's like we're making believe here. It's kind of strange, but yeah, we might need to mute a microphone or two. A little bit noisy in the background. But anyway, so if the square root of 1 is I, then what happens if you square both sides? You get I squared equals -1. So that's kind of the beginning point for this. The learning objectives, you see them there. There are 4 of them. We're going to use the imaginary unit I to write complex numbers. Then we're going to do all the operations, add, subtract, multiply. Division is just separated out as number 3. Write the quotient, the division of 2 complex numbers. And we're going to spend a little time talking about standard complex form. And then the 4th one, find complex solutions of quadratic equations. So the first thing I'd like to show you, you already know. I mean, this is review. If you were asked to solve by completing the square, have all of you got that down now? The idea here is what? Make sure. Let me get my pen operational here. You first want to make sure that the coefficient of x squared is 1, which in this particular problem is. Then what? You basically vacate the constant, get it on the other side, which I did by subtracting from both sides. And now you go through the completing the square process. Locate the b guy, 6, take half of it, 3, square it, 9. Because we're in an equation, we now, if we add 9, that'll make this thing a perfect square trinomial. And of course, if we add 9 to the left, we have to add 9 to the right. Now we can write it as a perfect square. And then, okay, we can extract roots. So the next step is extract roots. Now this is where in the previous lessons we would have called a halt, because we are now out of the set of real numbers. We used to say, no, we can't take that square root, but now we actually can at least proceed and call it that, use that terminology we talked about at the beginning. So we can take the square root of -3, and I should have gone one step further. You know, I added -3 to both sides. Well, you could think of this as negative 1 times 3, and that, of course, is the same as the square root of negative 1 times the square root of 3. And now we have a way to say the square root of negative 1. So we would say negative 3 plus or minus I times the square root of 3. So the only reason I really put this up was for review, and then to note that now we can proceed and actually write those things down, and we can make good use of them. And the good news is all this I stuff follows the same rules that we've learned for real numbers. So this is just kind of a review, but now I want to show you, hey, when you do get a negative under the root, remember yesterday we talked about the discriminant in the quadratic? When that b squared minus 4ac was negative, we used to say, whoop, no real answers, we'd stop. Now we can proceed. And that might be what I'm doing next here. Here we go with the, pointing at the next slide here. Well, yeah, let's just talk about, so what, review question, what do we know about conjugates? If you multiply conjugates in the real numbers, like a plus b times a minus b, what happens? You get the difference of two squares, right? A squared minus b squared. And so you can factor a squared minus b squared, but up until now we've never been able to factor the sum of two squares, a squared plus b squared. But guess what? We can if we use imaginary numbers and conjugates. So here I have two complex conjugates, a plus bi, a minus bi. You could say we actually do get the difference of two squares, but the last square, b squared, you know, what, you're going to have an I squared in there, and what is I squared equal to? Negative 1. And what happens when you subtract a negative 1? You actually wind up adding it. So if you look here, I just hand shook it out, did all four terms. We still do have an annihilation of the two middle terms. So we wind up with a squared minus b squared I squared. And now the simplification. I squared is equal to negative 1, so minus b squared times negative 1 actually becomes plus b squared. So thanks to complex numbers, we can now factor the sum of two squares. So the difference of two squares we factor with conjugates. The sum of two squares we can factor with complex conjugates. That's kind of a big deal. It opens up a lot of new factoring possibilities. Yeah, let's practice it. Here I clearly have given you the sum of two squares, x squared plus 16. Before this, we would have said, yep, can't do it. Now, let's use complex conjugates. X plus 4i, x minus 4i. And you can see, that works. So it's all this little tweak that there's an I in there, and when you square I, you get I squared. And so this minus 16i squared, because of the negative 1 factor there, actually becomes plus 16. All right, our next picture, yeah, this is just a typical complex number multiplication problem. Handshaking, you do your form. There is one little tweak though that comes out of this. First, I got to mention this: I is not a variable. All I is our name for the square root of negative 1. But I have good news for you. It acts algebraically like a variable. So when you multiply this out, you can see 2 times 7 is 14. Then 2 times negative 5i is negative 10i. 4i times 7 is positive 28i. And a positive 4i times a negative 5i is a negative 20i squared. Yes, we can combine those two inner terms. Even though I is not a variable, they act like that. So a negative 10i added to a 28i really is a positive 18i. And now we got this other tweak here, negative 20i squared is just another name for positive 20, so now we can also combine the two constants. And we get 34 plus 18i. By the way, this you see over here in the bottom, complex format that we regard as a standard is to put numbers in a plus bi form. So a represents the real number part, and bi represents the imaginary part. This is in that format, so we're good. So there's no surprise on this page at all, is there? I mean, except for watching the I squared here, there's nothing new here. It follows all the rules we learned in normal binomial multiplication. Even easier, let's do it. You're doing addition and subtraction of two complex numbers. Once again, when you're subtracting a quantity, you have to remember to carry that minus sign throughout the second polynomial. So when you rewrite it, it's 2 plus 4i minus 6 plus 3i. Now combine your like terms, put it in standard form. Very nothing surprising there. Yeah, this is just a reminder that you're going to see that throughout the assignment, usually they're going to ask you to put your answers in this form. Okay. So let's take a look at a quotient. I was going to do this over, but I thought, why not? I've got two problems up here. Let's look at the top one first. So here's the problem right here. 2 divided by 1 minus I. And the directions are simplify, put in standard form. So, how in the world, I mean, in standard form, here, let me just go back and emphasize this one more time. In standard form, we need to have the real number added to the imaginary number. We can't, and so when you go back to this first problem on this page we were just looking at, I can't have the I in the denominator like that. So your first step is, how in the world can I get that 1 minus I out of there? And just like earlier, conjugate is the answer. So what is the conjugate of 1 minus I? Hopefully you would see that it's 1 plus I, and of course, if I multiply the bottom of a fraction by a quantity, I have to do the top. Do you guys see where I got this to? Any of you guys that are, oh, I see everybody's got their mic muted. Yeah, you can unmute if you want.
Yeah, I see how that works.
So what do you get? You get the sum of two squares. So the real shortcut is, all right, what's 1 squared? 1. What's I squared? Negative 1, but it always turns out to be the sum. So we got a 1 and a 1, and so you wind up with 2. I mean, if you hammer it out, here it is, right here. The two middle terms wipe each other out. What's negative I squared? I squared is negative 1, so negative I squared is plus 1. 1 plus 1, 2. Okay, so you could say, well, we just passed off the I to the numerator. That's true. But now, notice we are lucky. We can do a simplification here. And this whole thing simplifies out to 1 plus I. There's another one down below. Again, another problem. Here's the problem again off here on the left. And again, you don't want that I in the denominator, so you start by multiplying top and bottom by the conjugate of the bottom. And we get the sum of two squares on the bottom. What's 4 squared? 16. What's 3 squared? 9. 16 plus 9, 25. Beautiful, no I's. On the top, well, we got to hammer that sweetheart out. See if you can tell what I did there. So 2 times 4 is 8. 2 times negative 3i is negative 6i. Negative I times 4 is negative 4i. Negative I times negative 3i is positive 3i squared, which translated is negative 3. Combine 8 minus 3 is 5. So we're down to this. That, however, is still not in standard. Even though this is correct, this is not in standard form. We don't have a plus bi. So now, notice what I did. I split it with the common. I went backwards, separated it out as two fractions with the same denominator, and then you have fractions that can be simplified. Here is our final a plus bi. That you're. Let's see, can you guys see that? Are the pictures in the way? Let's see. I'll scroll a little bit. You should be able to see it now. So that would be the answer that you'd find in the back of the book. Okay. So now I have it in a plus bi form. Questions? Don't be afraid to interrupt and ask me. And you guys, I'm not getting any text messages. That's fine, but don't forget, you can do that. You're welcome to. It's a little odd. I don't know. The only thing I don't like is I wish you guys would interact a little bit more, but I don't want to force you into that. All right. Let's take a look at another one. Yeah. Okay. Now, here's a little practice on rewriting in standard form. Okay? So, yeah, maybe what I should do is just cover this up for a minute, and let's just look at the top. Okay, now the top thing I did incorrectly. That's why it's crossed out in red. So I'd like to explain. Now, you know that normally with roots, and if you've got two separate roots being multiplied, can't you join those two things together under one root like I did right here? Normally you can. But and then what is negative 8 times negative 6? Well, that's positive 48. And then the square root of 48 we could simplify because that's what? 16 times 3, square root of 16. But that is actually incorrect. With negatives, here, I'll just show you. Here's the correct way to think of the problem. You got to separate, you got to get that negative out of there. So you see how I wrote negative 8 as negative 1 times 8, and negative 6 I wrote as negative 1 times 6. Now, you need to, you know, that's two separate roots, and I know it sounds gruesome, but you have to remove the i's first. Sounds like I'm into torture or something here. You got to remove the i's, but you do. So now that I've got that square root of negative 1, I can call that I. I can call this one I. Okay, now I can join the 8 and the 6 to get the square root of 48, but you notice the I times I is an I squared. There's the correct answer. Do you see what's wrong on the top there? Yeah, it's dead wrong. I've got the sign wrong. So, caution. Here's a slight modification of the rule we learned with simplifying roots. You really need to get those negatives, those negative ones separated and remove the i's before you finish up the simplification process. Okay, so that one I'm guessing you may want to make special note of because that one, I've seen that fool a number of people. Maybe I should have paused there. Anybody have a question on that? I'll go back there again. Do you see what happened there? So don't do it the way the top line is done. That led to an incorrect solution. Rather, get those negative ones out of each quantity, turn them into i's, then go ahead and simplify your roots, and of course, simplify any I expression. You will get the correct signed answer when you do it that way. Okay, so watch out for that one. Now let's go to this next slide. There's nothing really earth-shaking here, except that the past couple days, this would have been a roadblock. X squared plus 9, we can get the x squared by itself in preparation for extracting roots, but then when you get to this step, the next step, you would have quit right here because, wait a minute, no square can equal a negative. And we would have stopped and said no solution. Because of complex numbers, we can now proceed with the square root, positive and negative, of -9. And we actually do get two complex solutions. Likewise, here's another one. X squared plus 6x plus 15. We could solve this by completing the square. Get the 15 out of there. Now take half of, check that there's a 1 out here. Take half of the 6, 3. 3 squared is 9. Add 9 to both sides. You've seen this. Now I have a perfect square. Take the square roots of both sides. And again, we would have stopped right here and said, well, we can't solve this over the real numbers, and you can't. But over the complex numbers, you can. And we get two complex solutions. So we're expanding your horizons here. We're not just talking real answers today. We're talking real and complex means real and imaginary. Been using the word a little bit wrong. All right. Next. Yeah, just another up on the top there. How would we simplify the square root of -32? Remember, get that -1 out of there. So you notice how I broke it down into 3 factors. Why did I pick these 3? Well, -1, following my own advice, get that negative out of there. 16, why is that there? Because it's a perfect square. 2, well, we'll be out of luck with that. But I can take the square root of 16, that's 4. I can take the square root of -1, that's I. And I'm left with the square root of 2. Hey, I got a question for you. If we were doing this problem up at the top here, and the book said, put your answer in standard complex form, how could you answer that? You just need a real number plus the imaginary number. You could just say 0 plus. We usually like to have the I on the end. By the way, a little danger there. The danger in putting I on the end is if you're a little bit sloppy and you have a long square root sign on the top, somebody might misinterpret and think your I is under the root. You know what I mean if you did this? And you don't want that to happen. So usually we'll leave the I in the front like this. So that's another little tiny thing to kind of watch for. Okay. So here's another, now let's go below the line here. I'll put a line in here. The one below the line, how could you cube 3 minus 3i? Well, you know by now, is there a shortcut for cubing a binomial? Is there a shortcut for doing a plus b quantity cube? You should know by now that there is not. I had some of you I know on your chapter P test tried to do that. Yeah, I sure wish that was true. A plus b quantity cubed is not a cubed plus b cubed. There's a bunch of fun middle terms in there. So anyway, you got to do it first. You just have to multiply 2 of them. And then when you're all done, you got to multiply by a third. There is just no shortcut there. So anyway, here's my first 2. 3 minus 3i, 3 minus 3i. Hammered it out. Here's what I got. Okay, we got 2 terms that are alike. -9i, -9i would be -18i. What? There's a little bit I didn't show here. What is 9i squared equal to? -9, right? And what's 9 plus a -9? That wipes out. So all I really had left here was -18i. So this is my answer from the first part. Now I got to multiply it by the third 3 minus 3i. And yeah, I don't know if there's anything to comment on, just distributive property. Maybe a little tiny thing, just a comment on this. What's different about this bottom line than the middle one? It's just clearly an A plus BI form. It's not a big deal. Either one of these two would be correct on the bottom. All right. So now, let's talk about taking I to a number of different powers. Well, if you take I times, just one I, there's nothing to do there. If you take I squared, we all know the answer is -1. That's how we defined it. Well, what happens when you take I cubed? Well, isn't that I squared times I? And what's a shortcut for I squared? -1. So isn't this the same as -1 times I? Yeah, so there would be our simplified answer. How about I to the 4th? Isn't that just I squared times I squared? And isn't each I squared a -1? And what's -1 times -1? 1. And then if you keep going up here, let's just do one more. Let's do I to the 5th. I to the 5th is what? You may think this is strange, but I wrote it this way. I squared, that'll give me 4 of them, and then times one more I, so I get 5. Why did I write it this way? Because I squared is the one guy we know, right? What's I squared equal to? -1. What's -1 times itself? +1. And what's 1 times I? I. Now, I put a little line here because, do you notice something? I did all the way down to I to the 8th. Look at that. Look at this list of answers in this column. Look, we got I, -1, I, 1. I, -1, I, 1. You see how that cycle repeats? Yeah, and it will keep repeating. So, look over here on the right. What if I asked you to take I to the 83rd power? Pure torture? Isn't that just I squared 41 times? That would give me what? 82 I's. And then another one gives me 83. Well, what's I squared? -1. And what's -1 41 times as a factor? -1. Oh, and -1 times I is -I. See, here we go with one of these answers over here again. Here. You want to be ridiculous? What's I to the 6001 power? Well, it's I squared how many times? 3,000. That gives me 6,000. And then all I need is one more. Okay, so what happens when you take -1 to an even number of times 3,000? That's a +1. And what's 1 times I? I. So you see how all the answers of I to a power boil down to these 4? And they're actually pretty quick to do. You're going to see there's some things in the assignment where they'll ask you to handle I to different powers. Okay, so let's go to some examples from the 1-5 assignment. The first one I've got down here is number 57. So if you have your books handy, you might want to just check that out. 57. And the directions above 57 say, write the quotient in standard form. So, yeah, let me cover up a little bit here. I got too much visible. So there's the original problem on the left there. 3i over 4 minus 5i squared. Now, you can do it on your own. I mean, I just hammered this out. Do you remember the shortcut for squaring a binomial? You square the first term, you square the last term, and then you take the first times the second, 20i, and double it. Remember that? Anyway, all I did was hammer the bottom out, and I got this. Okay, can you do anything to simplify this denominator? Well, you got an I squared, so that can be made a -1, right? So this last term is just the same as negative 25. Okay? And what's 16 minus 25? Negative 9. So that's where this comes from. Negative 9 minus 40i. But we don't want an I in the bottom. So now it's time to pull out the conjugate. What's the conjugate of our denominator? Negative 9 plus 40i. Multiply top and bottom by that. Okay. So where did I get this 1,681? Well, shouldn't that be the sum of two squares because we're multiplying two complex conjugates? So what's 9 squared? 81. What's 40 squared? 1,600. What's 1,600 plus 81? 1,681. That's all I had to do to get that denominator. On top, just do the distributive property. Okay, so we're down to this. Is that your answer? It's good, but it's not in the standard form of a plus bi. So you got to do a little bit more. You got to kind of break it up into two separate, kind of go backwards. Take that common denominator and make two separate fractions out of it, and then see if you can simplify those. And I don't believe those can be simplified any further. But you would actually have to check the numbers. Does 3 go into the 1681? 5, 15, 18. Nope, it doesn't. So I'm pretty sure that's simplified. And I know that looks odd, but that's there's a standard complex form answer for that problem. Questions? Let's look at 65. This is from a different section in the assignment, number 65. It says here, solve by using the quadratic formula. Well, you guys all know the quadratic formula. There's one difference, and that is, look right here. We wind up with a negative under the square root, and again, what did we say yesterday? If the discriminant is negative, there are no real answers. That is true. But we want you to go on and find the complex answers. So you still can deal with this. Break that down as negative 1 times 16. Square root of negative 1 is I. Square root of 16 is 4. So this is 4i. So now we can write it like this. And then you can factor a 4 out of the top and do a little canceling. We're still not quite done. You can now split that up so you get a plus b form, divide each one by 2, and this would be your final result. So don't stop at this point right here now. And again, that's why I put it in here, because previously we would have halted there. All right. 69. Next one I'd like to look at. So I guess we have another one. I don't know. Maybe we can go. This is the same kind. Just the only difference here is you wind up with a fraction for a, but still. By the way, a good habit. When you're writing out your b squared minus 4ac, I like to keep them intact. So like, there's my b is 6 and negative 6, and negative 6 squared is 36. There's my b squared minus 4, and then I put a in parentheses and c. If you try multiplying that out right away, sometimes you can slip up a bit. Notice we got a negative. Don't stop. Keep going. Okay. Let's go to, oh yeah, this is a curious one. Number 81. Number 81 on page 129. They want you to, and by the way, I'm doing 8B. There's 3 parts. Wow. Do you believe A? Take a look at 81A. Do you think you can cube too? Yeah, that's of course 8. But what is the answer in complex form? Standard form, you could say what? 8 plus 0i. So if you look in the back and go, what's that doing there? That's the old a plus bi thing again. All right. So anyway, part C. We got to take this thing and cube it. Remember, no shortcut. And so first you handshake out this binomial multiplied by itself. Combine the like terms, and that gave me this. And then you got to multiply it by a third negative 1 minus square root of 3i. I just found this really curious. Look at the answer. So what we just found out is there's another cube root of 8. Not just 2, but this thing is the cube root of 8. This negative 1 minus the square root of 3i. So I'm not going to actually hammer this out because it's just more like term combination and that type of thing. But I wanted to show you that. That's interesting. So if you count complex numbers, there might even be some additional roots that you never thought of before. Okay, let's look at number 101. Well, that's a review. I don't know, do we? Maybe we don't need to do that. Let's just look at it. A mixture problem. We all have little challenges with mixture problems, so let's look at that. So we've got a 5-liter container contains a mixture with a concentration of 50%. How much of this mixture do you have to take out and replace it with a 100% concentrate to bring it from 50% up to 60%? So I guess I didn't show the total roll very well. But, you know, here up above this red line, those are your basics. You've got the amount times what I'm calling the rate, R. The rate, 50%. And yeah, what's different about this is instead of breaking into 2 parts, we originally did all 5, what was it, liters? Yeah, we originally did all 5 liters at 50%. So what was the amount of concentrate? Rate, amount times rate, half times 5 is 2.5. Now we're supposed to actually remove a certain number of liters, that's the minus x. It still will be a 50% concentrate, and then add it to the same amount, x, that you just removed, times a 100% concentration, and that should equal all 5 liters at 60%. So here is our, I usually have the equation vertical, but here is our, that's the equation we need to solve the problem. And then you can go ahead and work it out. You can see I came up with 1 liter. So of the original 5 liters, you would have to pull a full liter out, replace it with a full liter at 100%, and you'll get your wish. One more we'll take a look at that I've got, and then you may have some. I guess we already did that, didn't we? Yeah. Okay, so let me first show you, here's the assignment I would like you to work on for next time. The assignment we've been talking about, and the odds from, yeah, 1 to 83 odds. So I guess on that, when I did 101, I went a little further, but that's fine. We needed review on mixture problems anyway. Notice this time I'm having you do not every other odd, but all the odds. Okay, how are we doing here? We're at about pretty close to 50 minutes. Questions? I'm sorry I don't like it when I do all the talking, but any problems anything that came up that was fuzzy, or if somebody want to bring up a question from the previous assignment, that would be great. Again, I'm waiting online. I'm not seeing any text messages from our non-fully connected people. By the way, you three, you were that day when we did that experiment in class. And when I remember when we connected in class, and a few of you connected.
Right. Yeah.
Were you guys all one of those? I know, Nate, you were.
I was one.
Drew, were you connected that time?
I was not connected that time. No.
Oh, so this is new for you. How about you, Noah?
No, I didn't connect.
Okay, so it's not the same. It's not. Okay. Well, at least 3 of you have experienced what this really is supposed to look like. And thanks for participating. If you'd rather communicate with me privately, go ahead and send me a message or email or whatever you like. Thanks for being here today, guys.
Sounds good.
Yep. No problem.
Stop the broadcast then.